Hello, this is chapter 2, video number 3. Today we are going to be talking about the different shapes of distributions. Yesterday, or last video, I guess, we talked about what types of what types of graphs we could make with quantitative data. And now we are going to go ahead and talk about how we can describe them. So here are the ones that we're going to focus on today. We have 6 different distributions, and I'm going to go ahead and start with the one in the upper left. This is a nice bell-shaped distribution. This is uh, stated down below that it's symmetric and unimodal. Well, symmetric means that if I were to fold it in half, if you were to reflect that over, they would be the same on both sides. And then unimodal, mode is the most common, and that means singular, like a unicycle is one. So unimodal would mean that we have only one peak in here. So let's talk about a few things that could be bell-shaped. A few good examples. If you think about children when they're born, you have height, weight, head circumference. Any type of measurements, like human measurements, are typically bell-shaped. So we have height, weight, we have, I'm going to go ahead and say IQ. Typically, we have an average IQ here in the middle, and we have some people who are up in the 130s and higher, and some people who are in the 70s and lower. So anything that is normative like this, also standardized test scores. If you go back to your SAT and ACT data, typically you have a peak in the middle. You have some kids that perform better, some kids that perform lower, but any type of normative test score. Now, we are going to be calling this a normal distribution later on, and we'll talk about what that means if something is a normal distribution. All right, so skewed left, that is this one right here. We are skewed left. Now, skewed, you always want to think about what direction is it being pulled in. So this one is being pulled to the left, pulled to the left. So most of these items are here on the right, but it's almost like somebody is pulling the tail of like a cat and you're pulling it to the left. Now let's talk about a few things that could be skewed left. The example that I'm going to use are hearing aid patients. Let's think about why I would use that. Well, if you think of somebody who is using hearing aids, most often you would think of somebody who is old. The vast majority of people who are doing hearing aids are older. However, it is possible for a younger child with hearing loss or somebody with special needs. It is possible for children to need hearing aids. So, while most of the population that uses hearing aids is older, there are a few that are younger as well. Same thing with skewed right, except this is being pulled to the right. So we're thinking about something that is vastly used over here, but then it is being pulled to the right. So I'm going to go ahead and say AirPod users. AirPod users. I'm a high school teacher. I see a lot of kids with AirPods. Lots of AirPods in this general region. However, my grandma and grandpa are not using AirPods. I guess they have hearing aids, so they can't use AirPods. So skewed to the right, something that, and it's not necessarily age, but something that is mostly over here and then is skewed this direction. Another example would be number of siblings. Number of siblings. Think about it. Most people are either an only child or have one or two siblings. However, there are always those families like the Duggars or that have quite a few more kids than just the one or two siblings. So number of siblings would be skewed to the right as well. All right, uniform. Uniform is straight across. Boom. It is straight across. So this would be an example of this would be number of number of students in each grade. All right, I want you to think back to different graduating classes, and I'll go ahead and use my high school as an example. Typically, we always have right around 200 kids graduate every single year. Sometimes it's a little more, sometimes it's a little less. However, that number stays constant at most schools for the most part. You might have a high class or a low class. But also think about grade schools. That would be uniform. It's not like you have 10 sections of kindergarten and then only one section of sixth graders. It's typically, hey, we got 4 kindergarten classes, 4 first grade classes, maybe five second grade classes, but those are uniform distributions. All right, bimodal, last two. Bimodal is where we have two separate peaks of something, two separate peaks of something. And then finally, multimodal, that means that there are more than two. We don't really have any cool, I mean, I guess you could say trimodal and quadmodal, but multimodal is what we're going to go ahead and say with when there's more than two. Some good examples of multimodal. I'm going to go ahead and say McDonald's drive-through customers. Think about it. It peaks in the morning, peaks in the afternoon, and then it might peak at night as well. Uh, bimodal. Let's go ahead and say number of children sleeping. There's probably a really big peak at night of kids sleeping, and then it also peaks in the daytime as well when they are taking their naps. So, quick review. Symmetric. Here we go. We have that nice bell-shaped curve. And just as a heads up, you can be symmetric and not be bell-shaped. You could have a bimodal graph that is symmetric. If you fold it in half, it would be the same. But this is we're gonna go ahead and call this one bell-shaped. This one is skewed to the left. It's being pulled left. This one is skewed to the right and pulled right. And then finally, we have a uniform, bimodal, and multimodal distribution as well.